Hello. So this is the lesson that you missed today on Zoom. It's really important that you see this information and get this information. So I'm going to go through this quickly for you so you have it. So on Google Classroom, there is a document called Insulation Diagram 1. You need to open that document up, put it into Notability, and then put this video split screen with that so you can fill in the document as I go through it. All right, so here we go. We're going to start with this upper left-hand corner. It asks us for the tilt of the Earth's axis. If you don't know this by now, it's time to memorize it. It's 23½ degrees. So you want to write that on your document. The term parallelism is new for you. We haven't talked about this before. Parallelism refers to the fact that Earth's axis is always parallel to itself. So I'm going to write that down while you write that down. In other words, if you look at it in any position, it's going to be parallel to itself in other positions. So it's always pointing the same way. It's always tipped the same way. So if you look at this diagram, you can see that the axes are all lined up with each other. You know, they're all at that same angle. So that is parallelism. So there it is again. If you didn't get it, Earth's axis is always parallel to itself. So it's always tipped the same way. All right. So when you look at this diagram, you notice that we have 4 seasons represented by the 4 positions of the Earth at the beginning of those seasons. We need to figure out which one is which. The way we do that is we talk about summer. So up here in the upper right-hand corner, you see this box that says, how do we know which one is summer? If you watched the last video and took notes on it, you know we figure out summer by when the northern half of the Earth is tipped toward the sun. So we're going to say the North Pole is tipped toward the sun. So you should write that down. All right, so when the North Pole of the Earth is tipped toward the sun, that's summer. If you look at this diagram, you'll see that it's this one over here that is that way. You don't have to write that down, please. That one has the North Pole of the Earth tipped toward the sun. You'll also notice that that is also the one that's farthest from the sun, and that will always be true as well. So we know which one is summer because the North Pole is tipped toward the sun and it's farthest from the sun. If the diagram is drawn to scale, whichever one is drawn farthest from the sun is going to be summer. So hopefully you jotted that down. You can always stop the video to write stuff down if you need to. Okay, so that tells us that this first one is summer. So I'm going to write that right here. It is summer. And since it's the first day of the season, the first day of summer is June 21st. So we'll write that down. By the way, you need to memorize these dates. You need to memorize all this information. June 21st is known as the summer solstice. So write that. This basically is a review of what you already know from the other videos that you watched. The latitude, the direct rays. So this line right here represents the direct rays of the sun. Remember, direct rays means that the sunlight is coming straight down on you. So the direct rays of the sun are actually hitting this latitude line right here, and that latitude line happens to be 23½ degrees north because it's that same magic number as the tilt of the Earth. You need to know the tilt of the Earth is 23½ degrees, and the direct rays of the sun are at 23½ degrees north on the summer solstice. That 23½ degrees north, by the way, is called the Tropic of Cancer. The altitude of the noontime sun in the summer solstice is pretty high for us. It's 71½ degrees. Now, 71½ degrees is not 90 degrees. 90 degrees would be directly overhead. But in New York State, the sun doesn't get to us. The direct rays of the sun don't get to us because we live at 42 degrees north. So we live up here somewhere. So we're too far north to get the direct rays, which is why the highest the sun ever gets for us is 71½ degrees, which is where it is at noon on June 21st. All right, and then the duration of insolation for us in the summer, if you think about it, our days are really long, is 15 hours. Okay, so that's the summer Earth. Now, if you follow the arrows, this arrow here is telling us to go that way. So we go that way and we see the next Earth there. Now, this one is going to be the next season in order. So we already did summer. So this one must be the fall. The date for this one is September 23rd. And we call this the fall equinox. Equinox means equal days, equal nights. Every place on the face of the earth gets 12 hours of daylight and 12 hours of darkness on the equinoxes. So we can put that down for the duration of insolation. Since we happen to be on the face of the earth, we get 12 hours of insolation. The latitude of the direct rays, you can see this arrow is pointing toward the line in the middle of the earth, which is the equator. Easy to remember, latitude of the direct rays, equinox, equator, equinox, equator, equinox, equator. All right, the direct rays of the sun are on the equator during the equinoxes. And then the altitude of the noon sun is 48 degrees, which, by the way, happens to be exactly 23.5 degrees different from what it was in the summer. So if you subtract off 23.5, you get 48. All right, so that is the fall equinox. Then we go over here to the next one, which of course will be the next season, which is winter. So the date for the winter solstice is December 21st. That's the first day of winter, called the winter solstice. All right. It is the shortest day of the year as far as duration of insolation goes for us, and the sun is lowest in the sky for us on that date. So the latitude of the direct rays, you can see, are pointing right here to that dotted line below the equator, which is 23.5 degrees away from the equator. So this is 23.5 degrees south. The altitude of the noon sun is very low. It's only 24.5 degrees. You get that by subtracting 23.5 from 48, by the way. And the duration of insolation is only 9 hours on that date for us. If you remember, equinoxes is 12. You add 3, you get the winter or the summer solstice. You subtract 3, you get the winter solstice. All right. And then finally, we go up here to the spring. Which is our next season. The date is March 21st for the spring equinox. Again, equal days, equal nights for every place on the face of the earth. The only 2 days of the year that everywhere on the face of the earth gets 12 hours of daylight and 12 hours of darkness is on the equinoxes. So this is 12 hours for the duration. The latitude of the direct rays is once again on the equator. I forgot to put direct rays there. So it's on the equator, which of course is 0 degrees. And the altitude of the noon sun for us is once again 48 degrees. The numbers are the same for the equinoxes. I should have written direct rays down here on this one. And I should have written direct rays on this one. All right, so that is that information. The only 2 things we have left are the 2 things at the bottom here. When does summer begin south of the equator? Well, the seasons are opposite south of the equator as they are where we live, north of the equator. So when it is winter here, it's summer there. So summer begins south of the equator on December 21st. The reason it's summer there and not winter is because the angle of the sunlight is so high. So the direct rays of the sun are south of the equator for this. Sorry, I can't write and talk at the same time. So that is why they're getting summer in December, because they're getting more direct sunlight, higher intensity because it's at a higher angle. All right, the last thing that this particular paper asks us to do is draw the Earth at its current location. So let's see. So I want to draw the Earth. So you notice that this position for the Earth is September, this one right here, and this one over here is December, and we're looking for October 14th. Well, October 14th is between September and December, so I'm going to draw it right here, closer to October, sorry, closer to September than I am to December because October is closer to September. So I draw the Earth and it says draw the axis and the equator. So remember the axis has to be parallel to the other axes. That's parallelism. And the equator cuts across perpendicular to that. So it's going to look something like that. So this would be October 14th. All right. So that's the information that you missed. Hopefully you got it in that document because you need to know this information. This is something that you're going to be tested on and something that's required for the regents. Okay, thanks and have a great day.